Would you like to hear something?
So electronegativity is how much an atom attracts electrons in a bond. There's two things to look at. Well, before I tell you anything else, electronegativity, you're attracting electrons. The part that attracts electrons is protons. Protons are positive, opposite charges attract. So the positive protons attract the negative electrons. All right, as we go through this, feel free to pause, write things down, replay it, because I'm going to go kind of fast. I only get 15 minutes and then the videos won't let me upload them to YouTube, so I have to go fast. So if you're looking at electronegativity, there's two things you look at, shielding and protons. The more shielding electrons you have, the less electronegative you have. And that's because the shielding electrons are going to be electrons that are on the inner shell. So we're looking at how much an atom is going to attract the electrons on the outer shell to the nucleus. The more electrons you have on these inner shells, the more their negative charge is going to repel the negative charge of these electrons on the outside. So this would be more shielding than this. So this atom would attract its electrons more than this atom. Okay. If there's no difference in shielding, let's say I'm looking at two atoms that both have shells like that, where they both have two shielding electrons. If you have the same number of shielding electrons, then you start looking at protons. Protons are positive, they attract the electrons. So the more protons you have, the more electronegativity you have, because the more you're attracting those electrons. Play that again if you need to. So here's an example. We have lithium versus beryllium. First thing I want to do is write their electron configuration. So 1s2, 2s1. I'm using the periodic table. That tells me on the first shell there's 2 electrons. On the second shell there's 1. Beryllium is 1s2, 2s2. So on the first shell there's 2 electrons. On the second shell, also 2 electrons. Okay. So lithium has 2 electrons on an inner shell, 2 core electrons, so it has 2 shielding electrons. Se shielding electrons equals 2. The protons, it has 3 protons, which is the atomic number on the periodic table. So 3 protons. Beryllium also has 2 shielding electrons. There's 2 core electrons, but the protons here equal 4. So to figure out which is more electronegative, the shielding's the same, so I can't look at it. I look at protons. There's more protons here, so they're attracting the electrons more. So beryllium is more electronegative because it has more protons. Oops, protons. Okay, next example. Lithium versus sodium. So I want to draw the Bohr model and write the electron configuration again. 1s2, 2s1. So that's 2 electrons in the first shell, 1 electron in the outer shell. Sodium is 1s2, 2s2, 2p6, 3s1. Okay, so on the first shell there's going to be 2 electrons. On the second shell there's 2 plus 6 more. So 8 electrons on the second shell. And the third shell has 1 electron. Okay. So when I look at shielding electrons, there's only 2 shielding electrons, as we saw before, and there are 3 protons for lithium. For sodium, I'm going to have all of these electrons. So 2 plus these 8 is 10. So there are 10 shielding electrons for sodium, 10 electrons that are blocking this outer electron right here from experiencing this one. That's because these electrons move around. So all 10 of them are going to get in the way at some point. And the protons, I look on the periodic table, there's 11 protons. Okay, so first I look at shielding. This guy has less shielding, so there's more attraction. So the one that is more electronegative is going to be lithium because it has less shielding. Okay, next we have atomic radius. Atomic radius, radius of a circle can tell you how big a circle is. So if you have, here's the radius, that would be my circle. Or if I had, here's the radius, then that's my circle. So the bigger the radius, the bigger the circle. There's 2 things that you look at for atomic radius. You're just going to look at shielding and number of protons, and it's just the same as it was for electronegativity. If you have more shielding, those electrons are going to get farther and farther and farther away. There's more shells of electrons, plus they're less attracted to the nucleus. So since they're less attracted to the nucleus, they spread out more. If you had more protons, they get more attracted to the nucleus. So you could have the same number of shells, but if there's more protons, those positive protons draw the shells in and make the atom smaller. So let's look. Oh, and so if you need to write that down, shielding makes the radius bigger, protons make the radius smaller. So we have lithium versus beryllium again. I'm going to do the same thing where I'm just going to write my electron configurations. I'm going to draw my Bohr models, and then I'm going to look at these guys. So it's the exact same comparison. Let's see. 1s2, 2s1 for the lithium, 1s2, 2s2 for the beryllium. So they both have two core electrons, two electrons that are not valence electrons, so they both have two shielding electrons. The lithium has 3 protons, the beryllium has 4 protons. So we can't look at shielding, we just look at protons. Beryllium's 4 protons are going to attract those 4 electrons more, so just like a stronger magnet would pull and crush things in together, or anything pushing down on something that could be compressed, that could be compacted more, is going to get smaller, right? So it would be the difference between if I lightly compress this is how big this guy's going to be. But if I put in another proton right here, it attracts it even more. The compression's even stronger. I end up with a smaller radius. Okay, so this is drawn in more. So if I'm looking for which one is larger, I need less attraction, right? So it's going to be this guy. So lithium is larger because they have the same number of shells, but fewer protons to pull all those electrons in. So next example is going to be lithium and sodium. Okay, so once again, 1s2, 2s1. Draw our Bohr models, 2 electrons and then 1. And 1s2, 2s2, 2p6, 3s1. So we know we have 3 shells, 2 electrons in the first shell, 8 on the second, and 1 on the third. Okay, so this guy has those 2 shielding electrons. This guy has 10 shielding electrons. This has 11 protons, and this one has 3 protons. Okay, so now shielding electrons are different. That's more important to us, so we just look at those. Since this has an additional shell, there's more to be drawn in, plus there's more that's blocking this outer electron. It's going to be less attractive, it's going to be less compact, more spread out. So this is going to be bigger. So which is larger or has a greater atomic radius? Sodium is. It has more shells or more shielding electrons.